Hey, it's Matt Roush.
And Mike Brennan.
And we're back with our weekly visit from Fred Brown, our very own infectious disease expert here at the M Squared TechCast. Fred, good afternoon. And what's the story? What's going on right now in the world of the coronavirus?
Well, gosh, my life just got a lot easier because they opened up the Moderna safety and efficacy data today. And huge.
That was really good news, it looks like.
Yeah, I was watching the morning news reports and it was everywhere. That's, everyone jumped on that, so.
Well, I'll tell you, we've been working on the Pfizer vaccine to try to make sure we can distribute it. And Pfizer has a very challenging cold chain requirement. I think we talked about before, minus 70 degrees centigrade, it's minus 94 degrees Fahrenheit. And we have very few capabilities to transport that any distance, let alone to the facilities. If you look at what a drugstore would have in its facility, even a teaching hospital has in its facility, it may have one minus 70 degrees centigrade freezer to work with stem cells and things like that. But these freezers are challenging to get. And to make sure that everything stays cold that long before it even gets to the freezer is really a challenge. And so Moderna is different. It only has a cold chain requirement of minus 20, and that is significant because we
do that with dry ice, right?
Yeah. Well, we do have a slight dry ice shortage. Sadly, believe it or not, one of our things that are constrained. We don't have enough dry ice.
We had plenty of carbon dioxide. I thought we had too much of it, in fact.
So is that minus 20 Fahrenheit or centigrade?
Centigrade.
Wow. Okay.
Yeah.
So that's like 10 below Fahrenheit then. Okay.
Yeah, right. It turns out we're dealing with messenger RNA, and these things are incredibly fragile, right? The DNA double helix, the reason it was so hard to even figure out what that looked like is because we didn't even anticipate that van der Waals forces were going to, pull something together that was that significant to human existence. So we can't, when look Watson and Crick, when they constantly kind of looked at the double helix structure, we didn't think that was really even viable. But in fact, a biological system is sort of nice. It just barely holds together, and then it is able to open up and replicate, which makes it all work. But the problem with that is that if you're trying to actually transport this stuff, it's that fragile, right? I mean, it's just barely being held together, and then you're trying to transport it. And so what we do is we freeze it. And we freeze it at they go ultra low, or even cryo levels. Cryo levels minus 170. At ultra low is minus 70, and at that point, it stabilizes, and so we can transport it. Otherwise, if it gets exposed, it completely sort of crumbles up, and the efficacy of the vaccine just dissolves, literally and figuratively. So that's why we have this ultra cold chain. But I did run a couple of numbers for you guys. If you're interested, I can show you, or we can talk about other things, whatever you'd like.
Sounds great. I alerted people you were going to be coming on the show talking about this afternoon, so people are watching to get your opinion of what they came up with.
So I ran the numbers for Pfizer. In order to run these models, it takes quite a bit of work, and so we actually ran Monte Carlo simulations. And from that, I'll show you kind of what that came out with Pfizer numbers that are 90% effective. Now, when you have something that is 94.5% effective, you'll see it doesn't make that big a difference in terms of the population level, but it could make a difference for you at an individual level. So let's take a look at that. And that is, the point is, we're over 50%, we're over 60%, we're over 70%, we're over 80%, we're over 90%. It's just remarkable. To give you a sense, as I've worked in this space for 40 years, I've never worked on a vaccine, with the exception of mumps, that was at this level of efficacy. It's just very, very rare that you get this much. And the reason for that, as you know, I was looking at three scenarios. The first scenario I was looking at, I'll show you what I was looking at. I'll share my screen.
Well, the other thing is the focus group for this Moderna vaccine was like 30,000 people or something, right?
Yep. As for Pfizer also had about 37,000 people total. Okay. Now the difference was that they revealed a little bit more about what they found, and I'll go with the significance is huge. Pfizer said, we had 94 patients, and of them, we had 90% efficacy, which means you could be at a point where you had say that means you had to have more than, I think, 86 or 87, 86 in the cohort group, right? So 86 and 8 would have added up 94. So what they did is you vaccinate 37,000 people in this case, and then they let them go out into the world, and then you see whether they come down with something. And as soon as someone says, "Oh, I feel a little bit sick, I'm going to go get myself tested," they go, "Fine. What was the test result?" If say yes, then they say they score you and say, "Oh, so this person had an illness," and then but you don't know whether that person was the vaccinated group or the placebo group, right? You don't know that yet. And then when the FDA takes a look at it, when you actually do the analysis, this is an interim analysis, only the FDA looked at it, not the company. They said, wow, it turns out that of the 94 people, only 6 of those people were people who had been vaccinated, and we have 88 who were not vaccinated and they got the disease. That's a huge output, right? What they didn't tell you, though, is how severe the illness was. And that's something that we really look at carefully, because that really changes the death rate. It changes how much hospitalization you need. So if you vaccinate people and they get less severely ill, that's a huge endpoint. And Moderna, Pfizer didn't mention that. So how many people got severely ill? Moderna said of the people they tested, 11 of them in their group became severely ill. When they looked at those 11, they were all the people who had not gotten the vaccine. And that is really good news. So I did the work for Pfizer because I had the data for Pfizer. I didn't know what the result was going to be for Moderna. It's great news that it's similar. So it's going to be similar to this data. And so let me show you what I got. And maybe I think people might be interested. So let me show you what I got. I'll share the screen, and I'll try to go through pretty quick because this takes a long time. Unfortunately, this takes a long time to explain. We may have to have another session so that people, understand it. But I was following, as you know, 3 basic scenarios. The first scenario was get lucky, and that meant that we were counting on a vaccine, and basically the United States followed the strategy. They said, we're going to get a vaccine. We don't have to worry about anything else, and as a result, we have huge illnesses, and it was a huge bet. But if you win on the bet, you don't have as many deaths. You're able to open more quickly. You're able to have the V-shaped recovery. And initially, in April, I was skeptical because I've done a lot of vaccination. I've done a lot of vaccine development work in my career, and you don't want to count on a getting lucky scenario. It's fine if you kind of make a bet and you say, if I win the lottery, I'm going to retire next year, but I better keep working just in case. We didn't keep working. We just said we're going to go for the vaccine. We're going to go for the lottery win. And you know what? I think now you can see I went from 20% chance of that happening to a 70% chance. And now with Moderna, I think maybe as high as 90% chance we're going to have 2 vaccines in about December 20th, December 20th, kind of around Christmas.
Well, that'd be a nice Christmas present, huh?
I'll tell you, it solves so many problems for me. I'm so excited about this. I can't tell you, because what happens now is that before I was having to deal with Pfizer, very difficult cold chain, single manufacturer. Maybe it works, maybe it doesn't. We're not sure about all the results. Now we got 2 indications that things are working and 2 options, one of which is a little bit easier to manage. So this just, I'll tell you, I slept for the first time well in a long time. I'll do that for the first time in a long time. I did say we should continue to try to play the marathon, and you'll see why in a little while. And I did say that brutal was going to be that's really not what you want to go for. I think a lot of states fell into that inadvertently. They kind of said, well, we'll wait for the vaccine, we'll wait for and ultimately they started to realize, wow, we're having a lot of deaths, and maybe we'll get to a point where they have so many illnesses that we'll be able to prevent the infection. Well, that pushes you too far when you do the math. You don't want to have that scenario. But sometimes you fall into it because you pursue the get lucky strategy and you don't hit the get lucky strategy. That's like playing the lottery, not hitting it, having gone on, having challenges getting back into the employment range. So at any rate, that's what I was looking at, and the reason I didn't predict this, I knew it was possible, but I didn't predict it, was because you had to actually predict a revolution in science, and you don't really want to count on that. But I think right now we are actually in a revolution of science. And let me show you this slide in better detail here. And basically, it's a period of time where we actually have synthetic vaccine capabilities. What that means is you actually have the ability of a bacteria or a virus to infect your own body and control it, and then allow that disease to become present at a certain level, at least antigens to that disease, not the disease itself, at a certain level, which causes you then to create defense mechanisms that are permanent. And, just think about that, right? I mean, that is just awesome technology. When we harnessed the atom in the 1940s, we conquered space. This is really kind of demonstrating that at scale. And one benefit, I mean, if there's any benefit of a coronavirus like this, is that we, for the first time, we knew about this technology with at doses of 3,000 people with Ebola, or 2,000, or several hundred people with very rare diseases. We've done, and right now today we do some gene therapy work. We're talking about, drugs that cost $200,000 a piece and a dose, and you take it at once and you're cured from disease. But we're only manufacturing like 400 doses a year of this stuff. So this is the first time where we said, let's try it for 1 billion people, right? And we're gonna actually pull this off, which is shocking. And we'll talk about some of the challenges that remain. There's still some challenges that remain, but today I'd just like to talk about how amazing this is. And what that means is it goes beyond vaccines. This is something we've been working on for cancer. It's something we've been working on for antibiotics, for protein deficiencies, for carbohydrate deficiencies, for genetic disease. I mean, this is really a fundamental shift in our ability. And because we were under so much pressure, the regulators shifted their oversight of this as well simultaneously, which really allowed us to get unprecedented results. So what this bet was that 3 things. Number 1, we can completely change the sweet spot of vaccine development and what we're able to discover and use. We completely change the process by which we select those compounds. And that, by the way, we're going to change the entire regulatory process as well. So I can show you that, or I can show you what some of the results are. What would you like to see? Some of the results or the models? Well, yeah, so here's, so if you're, I think, have I shown you this? I think I have shown you this. So let me tell you about some of the models. Yep. So we've got this great vaccine, right?
Mm-hmm.
The question is, how great is it? And there are 4.
This one you showed us last week. So
I showed you this. So let's take a look at these 4 dimensions, right? Safety, efficacy, scalability, durability. I have some new thoughts about this. We've run some numbers. So there are 2 kinds of ways a vaccine can be effective, right? And you've just heard them say we're 90% effective. But what they didn't tell you is it really matters what that endpoint of efficacy means. And there are a lot of different endpoints of efficacy. So on the bottom of the slide, it says reduce mild symptoms, reduce severe symptoms, reduce the length of disease and transmission, reduce the length of general transmission, right? That's a spectrum of efficacy. And Pfizer could be telling the truth and have something that really isn't very helpful to us, or it could be revolutionary. And it really matters what you're testing for. Right now, we are testing for reducing mild symptoms. And the reason I say that is because Pfizer and Moderna, and in fact, every vaccine in development right now is only asking people, so, do you have any kind of symptom? If you have any kind of symptom, and in some cases they say, well, you have to have 2 of these, and you have to have at least a cough and a fever. If you have a cough and a fever, that's enough. You go to the hospital, you get checked out, we'll take a test, we'll see whether you got COVID. That's a pretty mild symptom, or if you lose your sense of taste. And now, if you're talking about fainting and not having enough blood supply to vital organs, and your lips are turning purple, that's a different level of saying, okay, you come to the hospital and get tested, right? And if you're stopping that kind of a symptom, that's a very different kind of clinical endpoint, clinical test, than just saying I got a case of the sniffles. So that's the fundamental difference of an endpoint. And then you can start to check whether or not that endpoint has been achieved or not. So suppose our endpoint, in this case, it's not the case, but let's make it simple, right? If our endpoint we chose was we want to have at least a 50% impact, which was what we said we wanted, at least 50%. The FDA said, you have that, you can get, we'll approve you. So suppose you have two things you're looking at. One is rate of transmission, and the other is whether you're reducing death rate. If your RT, that's the rate of transmission, is 3, then after 10 generations, you're going to have about 100,000 infections from one infection. That's a lot of people you can infect in 10 generations. You're talking over the course of a few weeks, right? Now, if you then reduce the death rate through your vaccine from say, and you have a 1% death rate to a 0.5% death rate, then that means you're going to have 1,000 deaths, right? 100,000 people of that 1% die. 1,000 people die. I reduced that by 50%. Now I'm down to 500 deaths, right? That's a 50% reduction, which is a great outcome. But if I had tested for something else, if I'd actually looked at reproductive rate and not looked at it and not been so interested in fatality rates, suppose we have an R, that's the reproductive rate of 3. After 10 generations, you got 100,000 again. Now, if R reduces by 50% to 1.5, and you do all the math, you only have 2,800 infections after 10 generations. Just think about how impactful that is, right? Because you're just not reproducing as fast. Then if you keep the same level of fatality rate, right? You didn't look at fatality rate, you're still at 1%. All of a sudden, you've gone from 1,000 deaths to just 28 deaths, right?
Wow.
That's a 97% reduction in the disease. So that's the difference between a clinical endpoint that says, I'm going to go after symptomologic kind of effect versus I'm going to go right after the virus itself. I'm not going to let that virus get to anybody else anymore. I'm going to kill it. And that's one thing helps us live longer. The other thing, and then stops hospitals from filling up. It really reduces the impact on our health system. The other fundamentally affects the virus because they can't find anywhere else to go anymore. So so endpoints are important. So watch for that. Watch for that. And right now, sadly, all you're going to find is, okay, we were able to reduce mild symptoms. That's all they tested for. So it's going to take us some time and additional testing, and we'll find it out eventually to find out what the actual impact on transmission was and whether you're really impacting the super severe symptoms or not. It turns out that if you only affect transmission, if you only say cure the sniffles and transmission doesn't decline, it could be that you're actually going to increase the amount of virus you've got, right? Because no one's going to go get treated for it. No one's going to stop. All I got is a sniffle. I'm going to go out to the bar and have a good time. You could actually start having more and more of this virus in place, allowing more and more mutations to occur, and maybe finding you eventually get to a superbug. The other issue that we look for in this space is antibody enhancement, where you actually the vaccine actually is encouraged by the immune system to reproduce, and we're looking for that quite carefully. And we actually stopped a trial because we thought we had an enhancement, and we'll get into that in a second. So does that make sense about efficacy? And here's what happens. So let's run some numbers. We run the models. These are very advanced models. They're just out. I just did it myself, and I simplified it a little bit because I know it's still confidential. But basically, what we said was we're right now at closing in on 1,500 cases a day. I'm sorry, deaths a day. We were between 1,000 and 1,500 deaths. We probably will increase that to slightly over 3,000 deaths per day by January 15th or so.
Wow.
That's a shame. That's how bad it's going to be. It's going to get bad. Now, the only thing that doesn't cause it to go to 7,000 or 8,000 is because I think we're going to have enough hospital beds if we act fast. I think we will. But if we run out of hospital beds, you're talking about double that. So hopefully that won't happen on a huge scale. I don't think it will, but it's still a scenario that's possible in a very bad situation. So suppose we go up to 3,000 deaths and we start to march our way down the curve after a while. I think we will. I think we'll have better policy. I think people will start to, after Christmas, people will start to naturally retreat into their homes a little bit more. And we're moving down that curve, and we introduce the vaccines as we think we will end of December. The EUA is going to take till the end of December. And then EUA means emergency use authorization. We will then, and you can see along the bottom, we're talking about the number of cumulative cases, people who've been vaccinated. So along the bottom, we said by 4/21, we'll have 20 million people vaccinated. By 9/21, we'll have 102 million. By 11/21, we'll have 195, and by 4/22, we'll have 242 million vaccinations. Now, I don't think that we're going to ever get to that level because there are enough people who are against vaccines and holding back and thinking about things before they want to get the vaccine. I don't think we're going to get to 242, but this is just, what's theoretically possible. And now that Moderna is also in the game, we could actually have this timeline. So that's a huge change, right? So we have Moderna, so we have right now, this is just for Pfizer. And you can see what happens. Basically, we continue, 20 million isn't that big a percent of the population. So it basically paralyzed the line that we would have without any vaccine at all. And then it starts to, we start to see a bigger separation if we're talking about reduction in transmission by 50% versus 90%. We're seeing some separation. And then but believe it or not, if we're able to get to over 220,000 vaccinations by January, February, we could see this. We could hit herd immunity and stop the virus, according to this scenario, at a 90% effectiveness rate. At a 50% effectiveness rate for reduction in transmission, it's going to take another 18 months, but eventually we'll get down to a level that's interesting. So that's what's happening there with transmission. Now, suppose we take the scenario where we're actually going to reduce the symptoms. So here again, we have the cumulative vaccinated population. This is the speed of OWS rollout predicted that we're working with now. We're going to change that obviously, but this is for Pfizer. And here you can see that instead of killing off the virus, what happens is you're able to kind of get to about between a third reduction and 2/3 reduction in the overall vaccine and overall death rate. You're moving from 3,000 deaths to 1,200 deaths, which is good. And then if you have the vaccine that reduces 50% reduction, you're going to get with a percentage about 900 deaths and 481 if a 90% reduction in symptoms. So I hope that makes sense, and you can see it in the curves and about how fast this could go if we roll out as we anticipate with under Operation Warp Speed. That's one factor. That's efficacy. So if we have a little bit of time, I'll talk a little bit about, and then there's dosing and
5 minutes.
Oh my goodness. Well, why don't we talk about safety next week then? Because safety is a really critical area, and we want to go into that in some detail. Dosing and routes of administration also make a big difference. So dosing, for example, if you're early on, Johnson & Johnson only requires 1 dose of the vaccine. If it's successful, we don't know what the efficacy is. We don't know. It's a different technology. It's adenovirus technology, vector technology, not an mRNA technology. What we do there is we actually insert a gene, a piece of the gene that you're interested in, transfecting into the human, into a viral vector. Take out the virus that's in the vector, put in the new one that we're interested in, inject it in, and that virus infects. Johnson & Johnson only needs 1 dose versus 2 doses. So if you're early on and trying to control the virus, 1 dose versus 2 doses does 2 things, right? Number one, it gets you immunogenicity 28 days faster, because you only have to have 1 dose and you're going to get immunogenicity versus having to wait for that extra dose before you really achieve it. The second thing it does is it doubles your capacity, right? Because you're moving from 1 dose to 2 doses. Same machine can produce basically in a simplistic way much more effective dose. So initially, it's very important to have between 1 dose, 2 doses. Eventually, the 2 doses catches up, right? Because you've got enough capacity, you're not constrained, you've got people interested in it. But you can see that basically, if you've got a 2-dose system, a 1-dose system, you can reduce symptoms and death rate due to symptoms that are bad if you're able to affect that by 20%, and for transmission blocking 10 to 20%. Now, the routes of administration also make a big difference because it gives you options. And if you have to inject everybody, there's some people who don't like injections and so on, some children and so on. And it gives you options in terms of the ingredients you're using, because some the misters use different ingredients than the injectors do. So it gives you some more options along the supply chain, which is important. But more importantly, it turns out that routes of administration make a difference in how effective a vaccine can be. We have seen misting technology used in animal studies that effectively do get to the lungs and make you much more resistant to the coronavirus if it's trying to attack your lungs, which is important. Upper respiratory tract is one of the 2 areas, nose and lungs, that really are attacked by the coronavirus initially. So if you can stop the lung part as well as the nose part, you're doing better. Turns out if you use intramuscular, it's very strong in the nose, but not much in the upper respiratory tract. If you use a mister, we're seeing evidence that we're actually going to get a better overall level of immunogenicity and effectiveness in the drug. So with that, why don't we talk about some other things, and we'll come back to the safety issues next week, because safety is really critical for vaccines when you're going to take them. And I hope this helps. It helps people decide which vaccine they're going to take. I hope people will look at this as the real transformation that it is. The reason that this thing went so fast is not because we cut corners. It's because we're looking at a revolution. It's the difference between, trying to get through the air space. Suppose you're trying to fly from Washington, D.C. to London. Well, now we have a jet plane. We don't have to use propellers anymore, and it's that much faster. Initially, people said, "Gosh, that's too dangerous. I don't want to get to London in less than 10 hours. It seems too fast to me." This is the same sort of thing. We're talking about a revolution in the technology, which allows a revolution in the speed at which we're able to develop the drug. With that,
about two minutes left. Let's talk real quick about, Governor Whitmer.
Yes, absolutely.
On Wednesday, we go into this sort of semi-lockdown with some restrictions, a lot of restrictions actually. And I think what she's trying to do is make sure people don't have a big Thanksgiving feast with everybody there and driving in and flying in and all that jazz. So then we'd have a super spreader event. So what are you thinking on that? Is that a good idea?
Yeah, it is. I think it is. What's happening is, I told you last time, we're getting to a doubling rate that's pretty dangerous. And the problem is that you think it doesn't look too dangerous, but that, don't forget, the death rates take 5 weeks to develop. So what we're seeing in cases right now, you won't see in death rate for another 5-6 weeks. And so she sees that, and she's using an early warning indicator to say, we're on an exponential curve. The cases are going to go up. And she's right. Now, as you know, I don't consult to her. I consult to a lot of other states, but sadly not Michigan. But I think what she did, I put her in literally, top 10%, top 20% of the state responses. She's done an excellent job. She's using the kinds of early warning indicators, not waiting until people get to the hospital, not waiting until people are dying. That she's using those early warning indicators and saying, we've got a super spreader event with Thanksgiving that's going to occur. If I can help prevent that, it'll be that much better at Christmas.
Traditional four-year students love Lawrence Technological University's thriving campus life, but LTU has always met non-traditional students' needs too. Lawrence Tech offers over 100 degree and certificate programs that can get adult students started or back on track. And most of our classes are conveniently offered evenings at our beautiful Southfield campus or online, so you can balance your social, family, and work life even while you power up your career. Lawrence Tech, where Blue Devils dare.